Faults and maintenance. For an electrical component that is mainly used in control circuits, relays have a lower chance of malfunctioning than other components, which are used to handle higher currents like contactors and circuit breakers. However, this does not mean that these devices are invincible, and like other components, they are going to break down eventually, but it's most likely going to take more time since they are exposed to lighter electrical loads most of the time. After going through the fault finding and maintenance techniques for the relay, you'll find that they are very similar to that of the contactor, which isn't surprising since the relay is the inspiration behind it. Conditions for a relay to be fully operational. So, for a relay to be fully operational, it must meet a few conditions. First, the contacts must have negligible to no resistance when closed and immeasurable to very high resistance when open, not allowing any current to pass through. This can be tested using a multimeter's continuity or resistance measuring option to test each of the contacts individually while in their on and off state. Second, the coil's measured resistance should be close or matching the manufacturer's info about the relay's coil. This could be done by testing with a multimeter's resistance measuring option at the terminals of the relay which connect to the coil. Some types of relays have the coil wired to electronic components, which makes it hard to test it with a mere multimeter at the terminals. In this case, we can apply an idle input, preferably from a power supply, to the relay and observe if it acts normally according to its function. The relay must act in accordance to its function consistently. And this condition should apply to all relays, but it is mostly relevant to relays that process the input signal with electronics or other means like time delay relays and thermal relays. This can be tested by applying an idle input to the relay and observing its operation for multiple times, making sure it's behaving adequately. And finally, we have that there shouldn't be any burning smell or buzzing sounds. Turning on the relay and paying attention to what you hear and smell will allow you to test this. The relay shouldn't emit any loud buzzing or burning odor. Troubleshooting a relay isn't as straightforward and general as other components since there are many types that differ in many ways. However, all of them are still relays and share a lot of commonalities. The fault finding techniques that will be mentioned are the most common and general across most types of relays. Nonetheless, you must keep in mind that each type of relay also has its own set of faults correlated with its function. So we'll start with relay doesn't operate when power is applied to it. In this case, you can start the troubleshooting process by pulling with moderate force on the input wires that power the coil of the relay to check if any of those wires are loose on the relay side. If the wires are tight, with a multimeter, check if there is any voltage at the terminals of those wires while power is applied to the relay. If voltage is absent or insufficient, then we can conclude that the fault resides in the control circuit. However, if voltage is present, you can move forward with the troubleshooting process. If the relay's coil is directly connected to the terminals, you can test it using resistance or continuity measuring with a multimeter and checking the health of the coil by comparing your measurements to the manufacturer's information about the relay's coil. If the measurement is zero, the coil is either open circuited or burnt, and hence the relay should be replaced. And if that's the case, you should investigate deeper into the control circuit, as a burnt or open circuited coil is most probably as a result of over or under voltage. Relay doesn't release when powered off. You are most likely to come across this fault when a relay's internal mechanics fail, as contact welding is a common reason for this fault, especially if large electrical currents relative to the relay are passing through its contacts. You can test for this with continuity at the terminals of the contacts in the relay's off state, but it's recommended to test it in both on and off state. And if the contacts aren't acting according to the relay's state, the relay should be replaced. If there is a delay in the release or doesn't turn off, check the voltage at the coil's terminals, as voltage leakage from the control circuit might be present even if the relay is supposedly turned off by it. In the case of special relays, another reason for delayed release can be the relay's internal electronic components, as those can become faulty due to unstable voltage or poor quality. After testing for leakage voltage and that being absent, you can take out the relay and test it in an isolated environment by providing it with an input from a precise power supply and observing its operation. Relay isn't consistent with its operation or behaving abnormally. There are a handful of reasons for this type of fault, since it is a very general statement to assume about the device. Nonetheless, we can narrow down the most common causes for it. This fault is mostly common among relays that perform functions like timer relays and safety relays, for example, since the traditional relay is merely an electrical switch, which isn't a complicated function. You can begin your fault-finding process by pulling with moderate force on the wires that supply the relay's input terminals to check if they're tightened. If they are, move on to testing the input voltage supplied by the control circuit to the relay's switching terminals, named A1 and A2 terminals in most relays, with a multimeter's voltage measuring option, considering that undervoltage is the most probable cause for this type of abnormal behavior. This drop in voltage might not be consistent, as in many cases it is another device with high starting current dropping the voltage of the control circuit only in its starting period. Search for high power devices like motors connected to the same feeder that powers the control circuit of the relay that you're testing, and start them while measuring the voltage at the relay's input terminals to observe if the abnormal behavior is tied to the starting period. If the relay's input voltage is adequate and not dropping under any circumstances, the relay is probably damaged and has to be replaced. Special function relays have electronic components inside of them, which makes them more sensitive than traditional electromagnetic relays to external effects like voltage drops and high temperatures, especially if they're of low quality, which makes them a great candidate for this type of fault, since not all electronics inside them fail at the same time most of the time, which makes them unstable with their operation. Taking out the relay and testing it in an isolated environment is recommended before replacing. However, replacing it before testing will solve the problem quicker. For relays with a base. A lot of industrial relays are split into two parts, the relay and the base. The base is merely a terminal board that can be installed onto a rail in a panel, and which a relay can be fitted into. The relay has pins that fit into slots in the base, and these slots are connected to the terminals where the wires can be placed. Depending on the quality of the base, after fitting the relay and removing it numerous times, the slots in the base become loose and might cause some resistance between them and the pins, or disconnect entirely, leading to all sorts of faults depending on which pin is not connected. This type of fault might look like the ones discussed before to a great degree. To make sure that the base isn't faulty before troubleshooting for any of the faults mentioned, try to fit the relay into the base and move it around so the pins might reconnect in the slots if they're faulty, and observe how it operates. If that is the case, it's recommended to replace the base. However, external vibrations or heat might cause the relay to detach from its base, causing this problem, making the base not the source of the fault.